So we're going to talk about section 1E, which is where functions meet. And though you might not recognize it just yet, you have done something like this before back in Algebra 1 and Algebra 2 when you took a look at where two linear functions intersected. Right? You've done that where you graphed those functions and you looked at where they touched. We've talked about solving systems and stuff already this year. This is a little bit different because instead of looking at where two lines cross, we're going to look at where a quadratic function and a linear function cross and kind of those different situations. So the stat box is all messed up, so we're going to just skip it, especially with the time that we have today. And just talk about where functions meet. So there's three possibilities that could happen. Three different things happen when we have a quadratic and a linear function meeting. The first thing that can happen, and this is all really, really similar to the numbers of solutions, because if we think about it, the x-axis is also a linear function. In this case, our linear function is just some kind of line. One thing that can happen is that that line could go through that parabola twice. It could have 2 points of intersection, and we call this cutting. Like it's cutting the parabola twice. Slicing right through it. Another situation is when there is just 1 point of intersection, and we call that touching. So just touches that parabola, only meeting at 1 point. But then we can also have the situation where that parabola and that line miss each other completely. And there are no points of intersection, and we call that missing. So we can do this graphically by using graphing programs. We're going to look at that just a little bit, but mostly we're going to solve these algebraically coming up next. Are we good? So here we go. We're going to look to see when the quadratic function y equals x squared plus 2x minus 5 intersects the linear function y equals negative 2x plus 7. And so these directions actually kind of tell us what to do. It says solve those equations simultaneously. And that's kind of like solving systems, but this is a little bit different because we have that squared term in it. Now notice they're both y equals, so essentially what we're going to do is a substitution and just set these equal to each other. So we're just going to set them equal to each other, bring it all over to one side, and solve it. There's a little bit more after that, but that's the basic first step. It might be a little bit different. So I really like to keep my x squared on the left and positive and all that. So I'm going to set up x squared plus 2x minus 5 equals negative 2x plus 7. And again, we can do that because they both equal y, so it's like a substitution. And we've had situations like this before. In fact, there was one on that quiz that we took last week. So we want to bring everything over to one side. So be careful with your signs. So we'll have to plus the 2x, just subtract the 7. So we get x squared plus 2x. Could you give me the pass, please?
Yes.
Thank you. So not going to be plus 2x. Thank you. So plus 4x minus 12 equals 0. it's your call. If it is factorable and you want to factor it, by all means factor it. If you really love complete the square, get some answers. If you think quadratic formula is the best because it works like with everything, then use quadratic formula. I'm not going to tell you which one to do. So this one is factorable. In fact, an odd coincidence, it's almost exactly like the one on the daily challenge. Did not plan that. So we could factor it. We could complete the square. We could do quadratic formula. What do you guys want to see? Factoring. All right. That's what I wanted to do, but I like to know how you guys are feeling. So factors of negative 12 that combine to get a positive 4 are going to be positive 6 and minus 2. So x plus 6 and x minus 2 equals 0. Now we know we use the null factor law and set them equal to 0, and we end up with x equals negative 6 or x equals negative 2, or positive 2. So x equals negative 6 and x equals 2. So we do have to do one little thing here because we're looking at when these guys cross. Well, this only gives us the x coordinates. We're talking about when graphs cross. We need an x and a y. So what we have to do is plug them back in to find the y coordinate. Now you can pick either of these. It's your choice. I'm going to pick the linear function because it's just less work. So I'll first plug negative 6 into that. So I'll have y equals negative 2 times negative 6 plus 7. I end up with 19. So one of my points of intersection then is at negative 6, 19. That is one part of my answer. Because again, I've got these points of intersection where those graphs are going to meet. I also have to plug 2 in. And when I plug 2 in there, I get 3. So 2, 3 is my other point of intersection. So if you sat down and you graphed both of these functions either by hand or using a graphing program and took a look, you would see that these are the 2 points that they intersect. And so it's one of those situations where the linear function cuts that quadratic function twice. Do we have any questions? Okay. So we're going to try another one here. Same thing. This time our quadratic function is y equals x squared minus 3x plus 2. The other linear function is y equals 2x minus 10. We will start this the exact same way by setting them equal to each other. So we've got x squared minus 3x plus 2 equals 2x minus 10. Bring everything over, so I have x squared minus 5x plus 12 equals 0. Just like I said before, now you get to choose if you want to factor, complete the square, or use quadratic formula. However, we don't have any factors of 12 that are going to combine to equal negative 5, so factoring is actually out of the picture. So it's one thing that if you really do love factoring, you have to be able to recognize when you can't use it. So we can either complete the square or use quadratic formula. What do you guys want to do? All right, so let's do it. Remember, I'm not going to write it down. You guys got that. You got your packet, right? So you can open that up. So we got the quadratic formula here. I've got the opposite of b plus and minus the square root of b squared minus 4ac all over 2a. So just plugging all those values in. Then we can start simplifying. So we've got 5 plus or minus. I end up with 25 minus 48 all over 2. Wait, what's 25 minus 48? A negative. It doesn't even really matter what it is. I think it might be 23. But that's a negative. Can I square root a negative? Nope. Can't square root a negative. So what do you think this means about where our line and our graph intersect? They don't intersect. So we would either say that this is one of those situations where it's missing, or if you want to write do not intersect, that would be fine too. So if you do come across something that would give you like a no solution, then we know that it does not intersect. They are not going to touch. Any questions about when we how to handle something like that? And if you did complete the square, you would end up with the same thing, trying to square root a negative and not being able to do that. Alright, I want you guys to do this one on your own. That is a minus sign. I had a little typo, so hopefully you can tell that that's minus 4. Try this one on your own. Remember, once you get x, to plug it in and solve for y. All right. Most of you guys that were able to finish, I believe I saw these answers. Now I don't think everyone quite got there, but 4, 1 is one of them, right? So we got x equals 4 plugged in and got 1. And then we also got x equals -1 and plugged in and got 6. If not, let me know and I can kind of glance at it. It's probably something like small that we can, adjust. So then what if you had something that looks like this? What if you had to figure out when x squared minus 4x plus 1 is greater than -x plus 5? What would you do if you saw that? Any ideas? And it's okay if you don't know. Really, the only thing we can do there is actually use a graph and take a look at a graph. Now, we don't have time with like the early release day to get into that too much, but I just want to show you what that looks like. So I already have these plugged into Desmos, and so notice they have the same intersection points, just like those points we just figured out. But if I'm looking for when this red one is greater than my blue one, I'm looking for when those y's are greater than, and we've got, see how the red one is above in this section right here? So when x is less than -1, as I'm going this way, that red one is greater than my blue part. Also, if I'm going this way, if I've got x is greater than 4, then I'm going to have that red one be greater than that blue line. So it's a little bit strange. We don't have too much time to dive into that today, but I just wanted to let you know that for those ones who do want to use some sort of graphing technology to help you out. All right, then coming back, we just need to quickly talk about the discriminant. And very, very similar to our different types of solutions. If we calculate the discriminant and it's positive, then it's going to touch twice. Be one of those cutting situations. If we calculate the discriminant and it equals 0, then it'll just touch once. If we calculate that discriminant and it is less than 0, then we know it does not touch. They will not intersect. So what we're going to do is actually have one of those situations like from section 1b when we're going to have a variable in there and kind of figure out what does that number have to be to create the given situation. Now, on top, I just had a little note to remember that tangent means touch once. I think we talked about it earlier in the year on some daily challenge, but just to keep that in mind, that tangent does mean touch once. Okay, so this is the situation. It says, for which value of c is the line y equals 2x plus c a tangent to the parabola y equals x squared minus 2x plus 5. So we've got this parabola. We want to know, where would that line have to be so that it just touches the parabola once? Because remember that tangent means it just touches once. So for that, we're looking for when the discriminant equals 0. We'll start it out the exact same way by setting it equal, even though we have that c in there and it's a little bit weird. So we'll have x squared minus 2x plus 5 equals 2x plus c. And we'll bring everything over to one side before we try to calculate that discriminant. Now it looks a little weird. So we've got to minus the 2x, and we minus c. So it's going to look a little bit strange, but we will have x squared minus 4x plus 5 minus c equals 0. Now, remember that discriminant is b squared minus 4ac. Well, my a is 1, b is -4. 5 minus c is actually what will go in our C spot. Even though we're not used to having an expression there, we're used to that being just a number. Well, C is a number. So it's not going to have a variable with it, and so that will be the C for our discriminant. Are we okay? Because then we're going to plug this stuff in. So I have negative 4 squared minus 4 times 1 times 5 minus C. And it's going to take us a couple steps here, but we're going to try and simplify this all out. So 4 squared is not bad. That's 16. 4 times 1 is 4. And then to get rid of those parentheses, then I can distribute that negative 4. So I have 16 minus 20 plus 4C. And wait, I don't know why I wrote 12 when I said 20, right? Did anyone else catch that? I think what's happening? I don't know. Early release. I'm going to blame it on early release. So 16 minus 20 is negative 4 plus 4C. I'm going to bring that up here. So negative 4 plus 4C is that discriminant. And now what we do next depends on our question. Our question, we want to find out where it's tangent. So because we're looking for tangent, I'm going to set that equal to 0. So if we were looking for the values for when it cuts it twice, we would set it greater than 0. If we were looking for the values for when they would not intersect at all, then we would set it less than 0. So kind of keep that in mind and go back to the question. We've got to add 4, so 4C equals 4. Divide by 4, C equals 1. So when I put that 1 in here, and if I were to graph it, if I were to get up Desmos and plug in this parabola and then plug in this line, and I would put 1 in for C, when I look, I would notice that it's just touching 1 time. Are we okay? You guys are all like, when can we leave, right? Hopefully. Early release. So when we get to this assignment, don't panic about it. Since we don't really have time to work on the graphing stuff, and this is the 1E assignment, just do that part that I circled, okay?